This
It's
conference
a
will now be recorded.
it's a customized version of Unix operating system.
What is Unix? Okay, what is Linux? Those who said you know. Okay. What else? Why do you need it? Okay. Good. Anything else? Open source? Anything? What is Windows? That's an operating system. Then what is Linux? It's also an operating system.
It's also an operating system.
Yeah, so the basic difference is both are operating system. So whatever you can do in Windows is what you can do it on Linux. But it was not Linux. Initially, they came up with the operating system called Unix. But the very basic understanding is that they wanted to do things in a better way. So to keep it in short, Windows as an operating system has certain limitations. So not drawbacks, but limitations. So in Windows, at any point of time, only a single user can work. So if you try to log in as a different user, it will log out. If you have not noted, we have multiple users connecting to the same machine. If one user tries to connect, the other user will get logged out. Okay, so that was one of the problems. So when you go to a company, you will have a huge machine. Okay, so you'll have like 30, 40 GB of RAM, multiple core CPUs. But still, if there's only one person who is going to work, then there's no advantage. So that is where they wanted an operating system in which multi-users will be there. Not just that, the other thing that you talk about, it's not much user friendly. If you think Windows is much user friendly, that is because of UI. But there's a lot of other things which you will not be able to, or you will not be able to. Whereas if you take the other operating system called Unix, it's much more friendly. Okay, and it's more of an open source, so a lot of people can customize it depending on your need. And the other primary reason why they went ahead with Unix as an operating system is it's much secure. So most of the time you see in Windows, you get some kind of virus attacks, trojans, right? But there is never such a scenario where in Unix you have something called as a virus attack. Okay. So these are the major advantages why they went ahead with the operating system called. But guys, can you mute? So keeping that in mind, when Unix started coming up, it's not just in now, it's there even before decades. So when they started coming up with Unix, like how Microsoft owned the Windows, Unix was being owned by various people. Okay, so Sun came up with their operating system like Sun OS or Solaris. IBM came up with AIX, DEC, and then HP came up with their operating system called HPUX. So like that, many people started owning their own Unix version, which was used for all their products. But it so happened again, from Unix, they started to create a new operating system, which is called as Linux, which was more of open source. Okay, so Linux and Unix are both one and the same, or you can call it as flavor. So in Linux, further, many other flavors started coming. That's where you would have seen FreeBSD as the first one, and then things started coming as Fedora, CentOS, you have Ubuntu, and then Red Hat licensed it and called it as Red Hat Enterprise. Okay, this is where from Unix it's kind of outdated. It's more of what? It's completely Linux OS now. So this is where Linux is just an OS. It is a Unix OS. Okay, just a flavor. So now, in that, regardless of whatever you're using as a user, you're going to get some common features. Only for administration, there are certain benefits you're going to get from a user level. It is all going to be the same. And any operating system that you take, this is the architecture on how it will be. Okay, so internally there will be a hardware, and to which there will be something called as kernel, which will be communicating. Whether it's your Windows or Linux, you're going to have a part which is the heart of the OS. So when you install OS, what is that you're going to have inside it? Which is what we call it as kernel. Okay. So whether it is Windows or Linux, you're going to have some kind of. Now that is where it is going to communicate to the users. So if you take a Linux machine, there will be a kernel which the user will be interacting. Whatever you tell, which will be to the kernel. In fact, kernel is nothing but the OS. Now, around the kernel, there will be a layer which will be helping us to communicate. So this is what we call it as a environment. So like in the class, if I want to communicate with you, I need a room or I need some kind of WebEx which will help you to communicate, right? Same way, if I have to talk to the kernel, now the kernel means if, for example, if you take this laptop, I'm directly communicating to the laptop because it is just in front of me. But in reality, in an organization, Linux system will be used by multiple users. That means the machine will be somewhere else in a remote location and you will be communicating to it. So in that way, for communicating between you or the user and the machine, there needs an environment. Like if I have to talk to you, if you are at home, I'll use a mobile phone or I'll use WhatsApp. So that is called as a environment. Same way, if we want to communicate between the OS or the kernel, then we need something called as a environment. And that environment, which is going to help us to communicate to a Linux machine, is what we call it as a shell. Okay, so which is nothing but a command prompt basically that you will be doing, because Linux, most of it doesn't have a UI. It does have a UI, but most of the people or most of the OS that don't have a UI. So you will be communicating to the kernel through a command prompt. Okay, so that way, that command prompt is giving you an environment, what we call it as a shell. Okay, now why do you call it as a shell? What do you understand by the word shell? What is shell? What is shell? What is shell?
Shell is an environment or a command line prompt where the user gives the input. I mean, what he needs. That's a shell.
That is what the answer I gave. But I'm asking you, what do you know by shell other than computer science? Which cover? Plastic cover? Seashell? Okay. Shell? Boat shell.
C cell, then born cell, then
Okay.
born again cell. That is base cell.
I'm asking you non-computer science shell. Have you seen shell anywhere? How did they came up with the word called shell?
Uh,
You don't know
Shell is
anything
like,
other than shell?
hello.
Seashell? Okay. Anywhere else?
So basically, C cell, which is protecting the kernel, right?
Yeah.
Hello.
Petrol bunk you would have seen, right? Seashell. So what is that? What do you mean by shell?
Protecting something.
No. What is a seashell? Okay, I'm going to the basics. I'm asking question. What is
Hello.
a?
Am I audible?
Yes.
It's kind of a hard protective, some case kind of thing.
Yeah. So basically, shell is a closed environment, and there's something, right? So why did they give this name? It's because when you're communicating to the kernel, you're not just getting an environment, but you're getting a closed environment. So it is not like your phone where I pick up, I dial your number, there is an environment given. But do you see there is a crosstalk happening sometime? Yes? No? Haven't had a crosstalk anytime in your life? So that means in your environment, someone else is coming, or you are going into some other's environment, right? You might be hearing something else when you wanted to talk to someone else. So now, think if that happens to your machine. I'm trying to communicate to one machine. What if the connection goes to some other machine? Is it secure? It's not possible, or it should not happen. That is where the environment, whatever we need, should be a closed environment. Closed means communication should be only from where I'm doing it to exactly where it wants. That's the reason they named it as shell. Okay, it does the closed. What is that? Environment. Okay, so sometimes we also call it as a nutshell. Even your nut, okay, it has a shell. So anything that you put is closed into it. So the same way, whatever the method that you are using to communicate to your environment or to your kernel, there is a shell which is available, which is a closed environment. Okay, that's where it's much more secure. Now, on top of that, there will be certain utilities. Utilities are nothing but your commands. Okay, so whatever the command you're typing, that is what we call it as utility or some application. So this is how basically it works. So in Linux, if you take, there were very beginning, there was different shells. Okay, now in the beginning, like again a decade back, C program was one of the popular programming, C++, C Sharp. So that way, now when a developer is using it, they wanted it to be more convenient for them to do the development. So that's where they came up with a shell called C shell. And then they came up with something called Con shell, KSH. Now on the same way, now the latest one, what everyone suggests to use because of the security is Bash. Stands for Bound Again Shell. Okay. So anytime that you connect to a Linux, the shell will be a Bash shell by default. Okay. Now there are certain properties that will be varying, but as of now, all the others are kind of outdated. So most of you will not even know the difference, but still, it's just a type of shell where there are certain specific properties to it. Now, what happens is anything that you communicate in Linux goes through as a process. So again, there is not much difference between your Windows or Linux because all these things are basics. Without it, it will be difficult for you to know. So what is a process in Linux or in an operating system? Those who said Uno Linux, what is a process? What is a process? A program. Okay.
Process is a set of commands.
Process is a set of commands. Sort of correct, but not completely. Okay, in general, what is process? Forget about machine.
It's a
What is
procedure.
process?
What do we follow?
Yeah, it's a procedure what we follow. So in an operating system, what is that you are doing? You ask something to the kernel. Now when I say kernel, that is the OS, and it gives you something. So anything that you are asking an OS or anything that the OS is doing is considered as a process, because anything that you call it as a process has an input, has a series of actions it will do, and it has an output, right? Anything. So now you're coming to a class. This is a process. So I have to initiate it, you come attend, and then finish, right? So that's again a process. So now in a Windows or a Linux machine, you tell something to the kernel. I want to watch a movie. I open a calculator. I write a document. I open a browser and things go. Guys, can you mute? So anything that you're going to do will be basically tracked as a process, because I am going to give an input to it and it will do something, right? And that is what you call it as processing. And then it's going to give me some output. So like this, whatever that you're going to do in a Linux is tracked as a process. In Windows also you have process. How many of you have seen a process in Windows? If you right click, task manager, so it will show you all the processes that is running here. All these things are a process. You can see anything that I'm running is a process. So whatever it is handling, that is the reason we call it as processing. So that way, in Linux or Windows, anything that you are interacting to the OS or kernel through your shell is a process. And in fact, the shell that it creates is also a process, because if I am connecting to the Linux, I open a command prompt which will have a shell. Someone else will connect to the machine, there will be a shell. Now, how will it know whatever I have asked, it should give it back to me. Whatever the other guy has asked, it should give it back to him. Because each of them is also a process. So your shell that it creates is also a process. Okay. So that way, everything that it is going to handle in Linux is a process. So typically, when you're working on Linux, what you need to understand is connect to the shell. Internally, that is a process, and every process will have a unique ID, which is what we call it as process ID or PID. Now, why is this needed? Using this only, the operating system or the kernel will understand that this process was created by this shell, and this is what is happening currently, and this is the feedback or the output that I should. So it will be handling everything with respect to that process only. And anything that you do after that is also a process. Like if I open a command prompt, nothing but a shell, and if I type a ls command or anything I do, each and every command is also tracked as a process, and every process will have a unique process ID. Okay, so that is how the kernel will be tracking what is happening and who created the process from which terminal. Terminal means the command prompt with which you are connecting. That is what we call it as terminal. Okay. So if you just open a command prompt in the machine, it is just a command prompt. If you connect from that command prompt to a machine, it becomes a terminal, or we call it as a terminal. That way, for everything, there will be a process created. So that way, when I open a command prompt or a terminal, there is a shell and there is a process created. And from there, any command that I type, there will be a process created. And as soon as the command gets over, the process is also over. So it is the other way. As soon as the process gets over, it will be displayed on the screen. So the kernel is going to track everything as a process. Okay, so that way, for all the commands that we are going to run, the command prompt that we have opened or the shell we have created will be the parent ID. Okay, because that parent process will be creating multiple other processes. So that is where, if you are opening a command prompt and you are running something, if you close the screen, the shell is stopped. Internally, the process which is running it is also stopped, and anything that is running in the process, your child command or script, will also get stopped. Okay, so remember, everything is a process, and every process will have a unique ID, and anything further from that process you are running something is also called as a process. But the first process is your shell, and all the others are called as child processes. Okay, now okay, I'm not going into permissions. So now, so just keep that in mind. So what I've done now is I've just created an AWS machine. So let me connect to it. So now basically I'm on my Windows machine. Okay, I'm just using git bash connect to a Linux machine. And for that, I'm using SSH. So if you have to connect from one Linux machine to another Linux machine, you're going to use SSH. Again, what is SSH? Secure shell. So this is also a shell or an environment. Why is it called as secure? Because to connect, it is going to ask us the username and password. So since it is AWS machine, I have given the name of the user, and using this PEM file, I'm passing the password. Okay. Now here, so I have now connected to this machine. Okay. So if you type PS, it will list you all the processes running by me. So right now, if you see, I am as a user called who? EC2 user. Now in this, how many processes are running? Why two? If you see, whatever currently I am running, it is a shell. What type of shell? Bash shell. So that is where I am still using it. So it is running. So this is a process. And then from this process or from this shell, I ran a command called PS, which will list all the processes. So because of that, this is also tracked as a process. So that is where at that time we had two processes. So out of this, now if you go ahead and do a PS -f, it will give you a full form. So now you can see who called this process, this user. The ID of this is 3403. Okay, and then the same way I ran this PS command. So for running this, there is a process from which process it ran. So you can now see PPID means parent process. So the parent process for this was my shell. This is how anything that you run will have a process, that you will have a process and a parent process. Okay, and every process that you run will return something called as a exit status. Using that only, the operating system or the parent shell will know that the child shell has completed or the child process has completed. So whenever you run some command, there will be an output. But now, who invoked this ps-f? Who invoked whoami or ps from this parent shell, which is 3403? So whenever these commands, whatever you are running, completes its execution, it will send a return status. Okay, there will be something like a status, which generally is some number. So by taking that status, the actual command will know whether it has been successfully completed or not. Okay, so that is how it will be tracking. So we'll talk about that deeper, but for now, just remember this much: it's a process where every process will have a parent ID and will also have a unique ID. Okay, now when you talk about this shell, which is nothing but environments, right? Now, when you come to a machine, there is something called as a variable. Okay, so in simple, variable is nothing but a place where you can store some data, which can be changing. It's not like it's going to be fixed. That's the reason we gave it as variable. Variable means varies. So what is the need of it? So there are many things in which you want to remember some value again and again. So in that case, what the operating system does is it will create some location in the memory and it will store some value. Okay, so variable is nothing but a address to find out your value. Okay, that way a variable is nothing but a location in the memory where it is going to store some value and you can reuse it whenever you want. But when it creates a variable, what operating system is going to do is it is going to create it in a process, because anything that has happening in a machine is through a process. Because if I want to communicate to the machine, it is using this shell, which is nothing but a process. So that way, whatever the environment that it is giving us is available only until this shell or process is available. Basically, this is a shell, right? Which is internally a process. So if the shell is closed, there is no such process and there will be no such environment given to us. So whatever it tracks in this environment, or as long as this environment is available, I will be able to get some value from the variable. Now, in that way, if the variable is used in this shell, then we call it as an environment variable. Okay, what is it? An environment variable. Why? Because you are using it in an environment. So what is my environment in which I am communicating? A bash. So you can also call it as bash variable. Okay. So this way, if I want to create an environment variable, that will be available as long as my process is available. What is my parent process? This one, 3403. So whatever I do will be available only on my parent process. Okay, so remember that. And to put it more diagrammatically, so when I create a process, so assume that in my command prompt, it created a shell like this. Okay, so this is my parent shell or parent process. So whenever I say shell, it is a process, right? Now, here, what is it running typically? Guys, can everyone mute, please? Okay. So now, what is it running actually here? It is running a I'm going to mute everyone now. So what is it running? It's running a bash. That is a command which is internally giving me a shell. But now, let's assume as soon as I run a ps command, what will this do? It will create a new process, and in that process, that ps command will be executed. Okay. And as soon as it completes, what will it do? It will send a return status. Then it will capture it and it will give you on the screen. Same way, any command that I run, it will be creating a new process, and inside that it will run anything. Even if I do a ls or any commands that you do will be through a process, and once it is completing, it's going to give back the return code. That way, now if I create a variable, basically you need to know where you are creating. Now you are working on this. Do you know what is this process? No, because who is creating this process? This parent process. Your bash shell is creating all these things, so you will not have a handle of this. So this way, if you are creating a variable, typically the variable will be available on this bash or this process. As long as this is available, it will be available. So now, how do you create a variable in Linux, which is nothing but a environment variable? So now, to create an environment variable, all you're going to do is you're going to give variable name. You're going to give variable name equal to the value that you want to store. So when you are using a variable name, okay, it usually has to be a string. Okay, so you can use capitals, it's not a problem, but do not use any special characters. Okay, and it should not begin with the number. So it should always begin from a alphabet, and it can end with the number. So it can be a combination of, what is it, alphabet and a number, but it should not be a number only or special characters. So for example, I can say something like my name equal to Adam, or I can say my name 1 equal to Adam. So this is possible. I cannot say something like this, which is not correct. I cannot say something like this. Okay, so remember, a variable always has to begin with the alphabet, and it can alternatively have a number in it. Okay, now there is a limitation on the characters. So for now, just assume anything you keep it less than 8 characters. It's a good practice. And you will say equal to, and on the right hand side, the value of it. So on the left hand side is the name, right hand side is the value. Now, as soon as you give this, in this shell, it will create a variable and it will store. So going forward, if you want the value, you should use this variable and this will give you the value that is stored in it. So for that, so let's say I'm going to do my name equal to Adam. So what it did, it just created and it is storing it in the memory. So if you want to retrieve the value, that is where anytime if you just say dollar and the variable name, it will give you the value. But just by saying dollar variable, you will not be able to get. So what do you want to do? So that is where you have to use that in some other scenario. So if you recall, there is a command called echo. So what will echo do? Anything that you give, it will print on the screen. So that way, if I say echo dollar variable name, whatever the value is it will print on the screen. So that way you can use it. Okay. See what happened. If I directly run dollar my name, it is converting it and it is taking it as a value. And it is like, if I run Adam, what will it say? No such command. That is what it is saying. So that's the reason you cannot directly use. So now if I say echo my name, it will give me the value stored in it. And now this will be available only until this process is available. Okay. As soon as the process is not there, it will not be available anymore. Okay. See this? I'm just switching the user. I was as root. I'm just switching the user. So it is not giving me. So it is available only on that shell. Okay. Remember, it will be available only in that shell. Got it? So this way, environment variable is nothing but a value which is stored and it will be available in the shell. So in this case, the OS also has lot of environment variables created by itself, because there are few things we create, but most of the things it will create by itself to track. For what purpose? For example, if you want to know what is the name of the machine, if it is Windows, what will you do? You'll go to my computer, you see an icon, double click, you will get an image. But in Linux, everything is command prompt. So that is the reason there are a lot of things the OS will store as a variable to remember. That you want to see the list of all the variables that is used by the operating system in the environment, you have to type env. So if you type env, you can see there are a lot of environment variables which are available. So out of that, one of them which we saw is the user or who am I, all those things are there. So now there is a variable called user in which it stores who is the user currently as whom you have logged in. Okay. And then if you say host, you say host name, it will return you the machine name on which you are working. Same way, if you say echo dollar shell, where shell is nothing but the environment variable name. So anything that the machine itself is creating, it will be usually in the capitals. So that way, if I say echo dollar shell, you will know it is bash. So this is how the OS stores certain values, and any shell that you create, it will immediately put that variable because it is created by the OS. But anything that we create will be available only in that process, not further. Getting it? Clear so far? But now, what will happen is, if you're opening, let's assume I am in the bash shell. But now let's assume if I run a command called once again bash, what will happen? It will create a new bash shell. So which is the parent? This is the parent. And now if I type bash, it will again create a new shell or a new process. So for this, your parent will be this one. Now, if you see, this is the parent shell and this is the child shell. Now, when you have such a thing, now all these are same example. This was parent, this was child. Now, if you create anything in the parent, usually it will not pass it on to the child or anywhere vice versa, because anything that you do in one shell or one process is known only to that process. Okay? So to understand this, now see, where am I? I am in this process called 3488. This is my parent. Now I'll say bash once again. Okay, so you didn't see the difference, but now if I do ps, do you see? This is the parent. Inside that, I created one more bash shell, that is 3545. If you want to see fully, now you see. For 3545, what is the parent? This one. So right now it is this example. I am in this. This 3545 is here. So now here, if I do something, it will not be available. Anything that you set in that shell will be available only in that shell. So if I do exit, what will happen? If you do a exit will return a status called non-zero. So anything which a process returns, if it is greater than 0, it is considered as a failure or stopped. If it is 0, it is considered as success. That way, now this process will be sending a return status to the parent saying that I have completed. That is where if I now say PS, you can see where you are. You are in the 3488. So this is how any environment that you set will be available only in that shell. It will not be available on all the child shell. So if you want to create an environment and if you want to pass from parent to child, then when you are running the variable, you just have to say an additional keyword called export. Export means it will export the value by passing it from parent shell to child shell. Okay. So in this, now you see, if I say export, my name equal to Adam. Okay. So now if I create a bash shell, and let's try this here. Got it? So this is how yeah. So if I create another bash, see, one bash will create another bash. That's how it will happen. But anytime you will be interacting with only one shell. Just for example, I'm showing you, but you will not be running multiple bash at a time. Anytime, whatever you do is on this parent process. And any command that you run, that will create another process. You will be handling only this. Yes. You can create, but at a time you will not be able to work. See, right now, how many processes I have created? 2 shells I have created, but am I communicating to both? No, at any point only one. So logically, if you ask me, just to show you the example I did, so why should I create one more shell? I could have done the same thing on that. So for my example, I created, but when you do something else, that will create a new process, but you will not be in that. You will always be on the parent only. That parent will call a child process. Okay, that is how it works. What if that is going to call another command? So there will be a lot of processes. Okay. Now, in this, one more thing what you remember is the variables will be exported only from a parent to a child. It's like a hierarchy. So if your dad is rich, you will be rich. If you are rich, your dad will not be rich. Isn't it? Yes? Most of the cases, yes. So anything that the parent shell has can export it to child shell. But anything which is there in a child shell, I cannot pass it on to parent. But I can create another child and I can pass to that. That is what we call it as hierarchy. So now, if you see here, let's say export, I will say my child name. Oh my. So let's say my, what is that? Okay, my value to child. Let's say echo dollar my val, you will get it. So now if I exit, and here if I do echo dollar my val, it doesn't. This is where, suppose if I have created a child shell from this, that would have had the value. Okay, so I'll show you once again. Now I'm in my parent process, create a shell. Now I'm in a child process. Now here if I say export my val equal child, okay. Now from this, let me create one more bash shell. So now I am in the child bash shell 3610, which is owned by this. Here if I say echo dollar my value, you will get it. That way hierarchy is parent to child, not from child to parent. Got this first? Okay. And in this, any point of time, if you're running some command, it will return a exit status, because now when I ran ls, what happened? It would have created a process. Inside that process, ls command will run, and the output of that is shown. And when it is completing, it will return a status. So that way, if I want to know the return status, there is a variable called dollar question. So when the dollar question mark says 0, that means the previous command or the process that you executed is success. Okay. That way, let's say I'm just saying ls Adam. What do you mean by ls Adam? List a file or a folder called Adam in my current folder. That way there is no such folder or file. So now you see if I say echo dollar question mark, it's saying a non-zero value. That means the previous command was not success. That is how the OS knows it. What will happen if I say echo dollar question mark again? Why is it showing 0 now? Because what is the previous command of this? Echo dollar question. Was that a problem in running it? No. So that's where it is success. Got it? Same way, if you say echo dollar dollar, that is double dollar, it is going to give you the process ID of your current process. So now, what is the process ID of the shell we are in? 3488, and that is what this double dollar is giving. Okay, got it? Okay. So now, like this, whatever you want to do, you will actually open a parent shell, and in this you will be typing your command, and for every command that you run, it will be opening a child process and it will be handling. Now, in Linux, at any point of time, I'll be able to run only one command at a time. Okay, but again, it's not mandatory that I cannot run two commands at a time. If I want to run two commands at a time, then anyone? That is the, like, for example, not quite. I am in this folder. So what I want to do is, I want to go to temp folder and create a file. So what should I do first? cd temp. So this is one command, and then I'm going to create a file, something like this. So what if I have to do two commands together? Yes. So this is where, if I go back to my home directory, so you have to use cd and whatever the command, and you can say ampersand. Okay, and then I can say touch new file. So now it is going to execute this command followed by this command. Okay, this is one way of doing it. The other way of doing it is, anyone? cd colon and okay. So where am I? Temp. It has created. So this will also work. Now, there is one more way. That is where if you want to do some activity, sometimes just by running one command, you will not be able to get the output. Okay. So there will be a lot of commands that you have to run. So in those scenarios, one of the way that usually we do is we use pipe. So what do you mean by pipe? Pipe is redirection. What is redirection? What is redirection? What do you mean by redirect?
Redirecting our output to another command.
General, what is redirect? In general, what do you mean by direct?
Changing the direction
So
to redirect.
redirect show to something else. If I asked you the assignment in the morning, what did you guys do? No, sir. Problem was my net laptop didn't work. Direct to something else, right? That is what we call it as redirection. Same way, in Linux, when you want to run many commands, you would need the output of one command and take that and do some other command. So that is what you can achieve through a redirection, which is where we use the pipe symbol. Okay. For example, now if I want to count how many files or folders are there, how can I do? So this is where if I do ls, it's going to list. But if I say ls pipe and word count -l, it will list. So now you can see by combining these two commands, wherein the output of one command is given as an input to the other command, and you will be able to get it. So this is one of the way that you can achieve it. But these are the things which you can do it on a normal use case. But if there are a complex thing that you want to do, which requires many commands, and it's not just many commands. So let's assume I want to run 10 commands, take the output, and I want to run another 10 commands, take the output of both, and then I want to do something else. Now, how will you start doing it? So typically now I have to run all these commands separately, at least 3 or 4 times I have to enter. Okay. So this is where in Linux, there will be a lot of things that you're going to do to your shell, and typically you have to automate all your work. So that is where whenever there is a task which involves you to run multiple commands, take the output, store it somewhere and reuse it somewhere, or you have to do it again and again. If you have to do all those things every time, you cannot do it manually. Okay, let me tell a very simple thing. Every half an hour, I want you to run ls command and tell me how many files are there. How will you run that? So you cannot run. But instead of you, something should run. So what is that something? That is where in Linux, if whatever the commands you are running, which needs multiple things to be done, then instead of running it in the command prompt, what you are going to do is we are going to put it into a file. Okay, then run that file, so that whenever you run the file, whatever the commands that is available inside the file will start executing it, and it will execute in a sequence. What is a sequence? In an order. So that way you can use this file and you can tell what are the things you want to run, what is the sequence it has to run, and how many times you want to run. Every time I can run. So suppose if I assume I have 50 commands to run, rather than me opening a command prompt and running this 50 commands, I can give this 50 commands inside a file, and if I run the file will run me 50 commands. So that way, these files are what we call it as a script. A script is nothing but your OS command, whatever that you are running on your command prompt or on your environment. Got it? But the difference is Rather than you running it directly on your command line, you're going to run it inside a file, which is what we call it as a script. Now, in this, what kind of commands you are running there? A shell command, because whatever that you are doing is called as OS or a shell command. That's the reason that script or file is what we call it as shell script. Similar to this, Windows also we have. So if I open a Windows command prompt, what do you call that? Bash command prompt. So that way, in Windows, there is also a file. We call it as bash script, which ends with .bat, right? The same way in Linux, if you are going to have a file in which you are going to keep the OS commands, which is the shell commands, and ask it to run, then that is what we call it as a shell script. So what is the need of a shell script? It is needed to automate whatever task you want in which there are multiple OS commands that you want to run. Or if there is something which you want to run again and again, you're going to use the same script. So instead of you doing it, now I can just run that script and that script will run 50 commands and I can just sit and watch. So that way I'm not sitting and doing everything. So it is reproducible easily and I can run again and again, and I can give the same file to someone else and anyone else can also run it. So that's how it is going to be easy and not just very simple. So your shell script is not just collection of command. If it was so simple, we don't need it really. But there are certain things wherein you have to put some logic to get some output. Okay, like here, whatever I'm saying, there needs to be some logic. That is where shell script is basically OS commands which you are going to run, but with some logic. Okay, so you will put some logic. Using that logic, it will run and it will give us some output. It's not very plain or stupid enough to just give some command. So you can give some logic to it, and based on that logic, I can tell what command to run, when to run, how to run, all those things. For all those who have gone through Ansible, we were taking the concepts of condition, looping, whatever you did through the basic scripting only. Because if you recall, Ansible internally uses Python. That is what we were seeing, right? Same way, shell is another script, which is a very simple or a basic kind of scripting which comes along with all the OS. So every OS has a shell. So it also supports a shell script. That when you put something into it, it will consider and run. Getting it? Clear? What do you mean by shell script? Because there are many things that you're going to do in a day-to-day, which needs multiple commands to run, which needs things to run again and again. You have to put some logic and get some output. All those things are there. So you cannot always keep doing everything through pipe or other way. That is where script. Especially if you are going to run a OS command, that is a shell command, then it is simply called as shell script. Getting it? So what you can do? Anything. Anything that you can do it in a OS, you can do. So any command that you are running on this command prompt can also be run inside your shell script. Because that is, now if you understand what is a shell script, it is also a process. Because now if I create a script and if I run it, what will happen? It will create a new process. And whatever the commands that you have given, it will be running in this process. That is where when you run a shell script, it will create a process and whatever the commands you have given inside the script will be executed inside the process. Got it? Getting it? Okay. This way, a shell script is a plain text file. Okay. It's not a binary file, it's a text file. So if you are creating a shell script, in Linux, there is no naming convention. Okay, because going back to basics, in Linux, everything is a file. That's the beauty where even if someone puts a virus, it's just a file you can delete. Okay, so that way, anything that you put will be a file only. Okay, so that way, it doesn't matter with any extension. But in Windows, it's not like that. Windows requires extension, right? So if I have a file which ends with .doc, what does it mean? document. If I change it, will you be able to open the file? No, right? But in Linux, it's not like that. You can give any name, it will still work. That way, you will not be able to differentiate. See, if I keep some file like this, how will you know what is script, what is not a script? That's the reason, anytime if you're creating a file, which is a shell script, it's always better to end it with a .sh. So which means that it is a shell script, okay? But there is no other meaning of that. Now, if I look at a file and if I have some name, I can give any name once again. Okay. Now this way, it is not a variable. So I can give a number, but not a special character, but I can give a number also. It will work. So this way, I can create a name.sh. So now what does it mean? It is a shell script, or the content inside it is a shell script. Okay. So it's a best practice that you have to follow. Still work. Doesn't matter. That's what I'm saying. Understanding. Now, if you have a file in Linux, by default, what are the permissions that you're going to have? Read, write, execute, right? For example, now I am in the home directory. If I create a file called one, okay? If I want to know the type of file, if I say the command called file space the file. Now let's say I put some content into it. So there is a line called dummy line in the file. Now if I check, what does it say? It says it's just a text file. Now, typically, if you take a Linux shell script, it is also a text file, but you are going to run it. So anything you want to run in Linux, it needs to have a executable permission. If you want to read it, it should have read. This is where, if you are creating a file and it is going to be a shell script, and you need to make sure it will be having a what? Executable permission. For example, now let me create a file. Okay, so I'll just call it as my script. Okay, without any extension. And in this, I will just run one command called ls. Okay, let me save this and come out. So now, if you want to call this script, this is where anything you want to call in an operating system, you will just give the command like this. Now, what does it say? It's saying command not found, because when you run a command, what will it do? Any command you run, what will it do? Why is it okay? Now, if I type ls, how is it giving this output? Why didn't it run this? First thing is, it doesn't have execute permission. Okay, because it's just a normal file. Now, how do I give the permission? Chmod +x. Okay, now I gave permission, so it became executable. So let's say now my script, still it is not finding. Why? Because anything that you are running, it will check in the path. So if you go back to basics, now anything you run, it will search for the path variable. So that way, where is your script now? Where is the script? My current directory. What is my current directory? Home EC2 user. Do you have home EC2 user here? It is not there. So that's the reason it doesn't. So there are two ways to run a script. Either you have to give the complete path. So what is the complete path? My home directory under that. So either I can say my home directory, wherein tilde is nothing but home directory / my script. It ran, because now it knows there is a file here. If not, the other way of running a script is I need to tell it is in my current directory. So how will I say it is in my current directory? How do you say current directory? Dot. So now if I say dot, it is my current directory / the script name. Got the difference? So now this is the only way. Now, if I have added the home directory inside my path variable, then if I just say my script, it will run. But usually Wherever you keep the script, every time you will not be adding variable. So if you have added, then you can now, for example, now I will say path variable equal to $path, which is my current value, and in that I'm going to add this. Okay, so now if I say my script, it's picking up because it knows. This is where, remember, you have to either give the full path or you have to give your current path where it is available. If not, add the path where it is available to the environment variable called path, and there it will be. Got it? So this is how you run your shell script. So now what is happening? Inside my shell script, what do I have? ls. So now if I run my script, what is it giving? ls command. So what is ls command? It is giving this output, and that is where your script is also doing. This way, any Linux command that I want to run, I can put into my script. Echo. So here I'm just giving a sequence one after the other. Okay. You can see first command it is running ls, and then it is running hello string. Got it? So it's going to run sequentially. Now, this is one way of running your shell script. Now, this is where what you need to know is every time you executed this, what happened was it created a new process, and inside that process it ran all those things. Okay, see that. Now if I open my script, okay, and inside this we will say echo $. What do you mean by $? Process ID of the current process, right? So now see, my parent process is 3715, and now if I run my script, what is happening? It is telling 3804, but is it there? No, it got completed. So as soon as it completed, there is no more ID. Got it? So that way, every script that you're running is a new process. But what kind of process was it? That is where anytime if I'm creating a new process, what is the default process set? Or what is the default shell set? What is the default shell? Bash. So every time you created, you are opening a new bash shell. Okay. Now, if you do not tell anything, it is just a plain file which is having some command, and it is using the default shell. But it is always a best practice wherein sometimes if someone is using some other shell and you want to use bash shell, that is where in every script, the very first line what you're going to have is a hash bang. Call it as bang. Okay. Now what does this mean is anything followed by this is the first process which should create, and all the commands under it should run in this way. Any kind of scripting that you take will be in this format. So what is this? So it means we are telling to the operating system, open a bin bash shell, and inside that you run all this. Okay, got it? That is how it is going to work. So if you don't tell, what will happen? If you don't tell, what did we do now? It will use the default process or the default shell, which is bash. Now here what am I doing? I am explicitly telling to use the bin bash. That's it. So if you run, you will not see any difference, but it is running using a bash shell. Got it? Hey, who's that? Can you please mute yourself? Getting it? So if you do not say, whatever say, now if I run ls command, what shell it is using? Bash shell. So the same thing inside your script also it will use. But if you explicitly tell, then it is going to use this and pick it up. So that is how now it will know this is a shell script, and it needs to run using bin bash, and all the commands further will be run in that shell. Okay, but now if you understand deeper, this will create one process, and that process will create 3 processes to run each one of them. Okay, so your parent process will call this shell script. Shell script will be a process, and that will call each of the command separately. Got it? Okay, so far, how do you create a shell script? How do you put values in it? Now, the same way, now to understand this, here, see this first example. Okay, there is nothing. So now I will set my name equal to Adam. So it is available in my current shell. So let me open my script. So in my script, here, if I say hello, dollar, my name, sorry. Now if I run it, what is it saying? It's not printing. Why? Why it's not printing? It is churning in the child shell. So we have not exported, right? Let's see the same thing. If I say export my name equal to Adam, and now if I run it, it is a child process. It is having. But the same way, if I do anything on the shell script, I'll not be able to get. So for example, here, anything that I set here. Okay. So now if I set here, so now this is available only in this process or shell. That's the reason if I run this, what does it say? It's available only there. Now if I run it on my machine here, what is it giving? Adam. So that way, anything that you create in a process is available only in the process. You can pass only from parent to child, but not from child to parent. Okay. Now, so I'm creating a variable, and here I'll say hi world. Okay, fine. Now, hi student, working fine. Okay. Now if I say echo dollar r, what is happening? It's not printing. What happened? Now, from where did I do this echo dollar? From my parent shell. It took it up. See, get what I'm asking you? I ran the script. Where was this variable stored? In the child. That's the reason when I did echo $UR, it didn't give me anything. But now I ran the same thing, and now if I'm seeing, I'm able to get. So then, was I wrong? Is the child passing it to parent? That is not at all possible. Then what is this? Magic. Obviously, there is nothing called child will pass to parent. But how is this happening here? This is where magic. The magic here is you are not telling to create a new process. Whenever you run a script, what is the line X going to do? It will create a new shell. So that is the reason it was a child shell. But when you say a dot here, it means run on my current shell itself. Don't create another process. So because of that, whatever the content you had in the script, where did it run? The current. So that is where, what did you have inside this? What did you have inside it? These two commands. So it ran on the current shell. So if I run this on the current shell, then where is it set? My current shell. So that's the reason I was able to get this value. What the difference? So there will be certain scenarios where you don't want to do this, then you're going to use this magic. But other than that, your child cannot pass anything to your parent shell. How many of you are giving pocket money to your parents? None. Right? There's no charitra for that. Yeah, there are some good guys. Most of us. Anyways, getting this? Clear with how do you run the shell script? What is a shell script? How do you call? What is that you're going to do? Basic thing. Any questions?